Hello and welcome to the RoboLudens tutorial. This is going to be a tutorial that we have called Game Design Techniques Applying in Human-Robot Interaction. And we hope all the content that we have prepared for you is helpful. We have prepared 4 different activities. The first is a Game Design Fundamentals for HRI Researchers lecture, in which we're going to be talking about game fundamental aspects of game design and different techniques used to design games when involving physically embodied robots. The second is an interview we did together with Professor Kirsten Dottingham about games and how she has been through these decades using games to foster interaction between human players and social agents. At the end, we are going to be presenting a lecture about taxonomy we did, which was trying to categorize different game elements and the different design aspects you should consider when creating games using social robots. We are proposing also a homework in which you will be able to use a tool called the Human-Robot Interaction Game Canvas. And the main idea here is that you will be able to fill out a template with different elements that we believe are important when trying to design games using social robots. My name is John. I'm from the University of Waterloo. I'm a postdoctoral researcher. My background is in human-computer interaction. I'm a game designer by passion. And I recently joined, 2-3 years ago, I joined the laboratory in social and intelligent robotics laboratory here at the University of Waterloo, led by Professor Kirsten Dottingham. This is our website that we have prepared for this tutorial, and all the materials and all the lectures will be available in that website. So take a look. So today's lecture is about game design and the fundamentals of game design. And I try to, based on my previous experience working with human-robot interaction researchers, I've tried to narrow down to make this a little bit more suitable for this specific field of research. So we will start in trying to dig into the difference between games and other types of digital media. Conventionally speaking, we have when we have digital media like TV shows, when you see videos in your computer, in your mobile phone, even when you're using virtual reality glasses to watch and observe different media, there's always a linear experience with the content. That means that as user, you are not able to modify anything that is happening in that specific media. So when it's a TV show, unless it's an interactive TV show, you want to be able to kind of like change the course of the different events that are happening. However, when it comes to video games, we normally empower participants with this ability, or players with this ability or capacity to be able to influence the events that are happening. So normally players, they tend to use game controllers or joysticks and provide specific user inputs to the system. Then the system is processing that input and reacting accordingly. And all of this happens in a closed loop manner. So this is what is called an interactive experience. So as players, as users of this specific system, you are capable to certainly modify the order or the effects, or certainly influence what is going to happen next. Now, what happens when we, instead of having like conventional, video game consoles, or when we are having conventional games, we have a socially interactive robot. So there's a couple of things that are going to change here, but I will say, the fundamental change that we will have is sometimes instead, or sometimes beyond having the conventional game interface to communicate the robot with the human, we also have all of the robot sensing capabilities. So the robot is certainly capable to track what is going on in the game, to track some of the participants' reactions and react accordingly. So beyond sometimes having an input from a game interface, or in addition to this game interface, we have cameras, we will have sensors and actuators. So the robot would be able to perceive what is happening inside the game, and is going to be able to create, to modify the gameplay to give this perception that the user is certainly under control of the experience. So therefore, in games, once compared to other different type of media, we give the player the opportunity to control over the pacing and sequence of events in the experience. That's a fundamental difference between games and all the types of media. There are many different frameworks, and there are many different ways in which we can classify or categorize the different elements of games. I'm using one that is called the elemental tetrad from a book of a very famous game designer called Jesse Chell. So he proposed 4 fundamental aspects, or 4 fundamental elements in which we can deconstruct each game. The first is called mechanics. So the mechanics is basically the core of the game. So the mechanics encompasses a set of procedures, rules, interactions, and all the relationships between the game element and the player. So any element that is related to the gameplay, how players can affect the gameplay, can be enclosed into this concept of game mechanics. And is mostly when you remove all the other elements, whatever stays in the game, that you can call the game mechanics. The second aspect, and this is probably one of the aspects that sometimes can be more complicated to differentiate, especially when working with robots, is called game technology. In the game technology, what we have is there's a medium. We propose a specific medium in which all the things are going to be happening. When we talk about technology, we don't want to limit this to information and communication technology. We don't want to limit this to computers, to virtual reality headsets and interfaces. So in a sense, any material used for the game to work. You're talking about car games. So in this case, the technology that I'm using is cards. When we are involving, for instance, dice to bring some probability inside the game, then this is part of the technology. The dice, same thing with any other timer element, for instance, that you use to facilitate the interaction with the board game. In the case of in the case of physically embodied robots, then we have the robot itself. Aesthetics is the third element, and in aesthetics is basically how the game looks. And over here, I want you to think beyond the visual aesthetics. I also want you to think about the sound that you can provide, how the game tastes and feels when you are interacting with the system. So sometimes you can either have super big cards, you can have small cards, you can have many different ways. There are many different ways to interpret the aesthetics or the artwork of the game. The final element is called story, and it's basically the narrative. So the sequence of events that will allow players to unfold the gameplay. So based on these 4 elements, this specific design framework called the elemental tetrad provides an overview of every aspect that any individual game will have. So any game can be deconstructed using these 4 fundamental aspects. So when it comes to to try to define which element is more visible than the other when playing with games, you will be surprised to see that certainly the first thing that you will relate to the game when you are interacting with something, the one that is more visible is certainly the element of the statics. So the cards, the art of the cards, the art of the virtual environment that you're creating in a video game. Then you see the story. The story is also certainly visible, especially those games that are very much story driven, and you can interact while you're reading what is happening and trying to understand the story. Then the less visible elements are actually the technology and the mechanics. So I'm going to bring you here an example of a game that I have been creating here at the University of Waterloo, and I'm going to show you here basically how to deconstruct, a very simple game using a social robot as Pepper into this main element that I just explained. Imagine a scenario in which we're using Pepper. There's this humanoid, child-sized humanoid, and imagine we want this game to, or we want a Pepper to be able to recognize some pieces that I put on a table, and this game that I'm using on a table is a puzzle-like game. In this case, the game is called Tangram. So Tangram, you basically have a set of pieces that you have to arrange following a specific shadow that, in this case, Pepper will be showing. So in this specific human-robot interaction scenario, Pepper is moderating how participants or players will play the Tangram game. So the mechanics over here is mostly the mechanics that are related to the game. In this case, is the puzzle solving. So Pepper is asking people basically to solve those specific puzzles provided by the Tangram game. The technology here is can be divided into two elements. So in one side, we have the robotic technology, which is in this case Pepper, with all the sensors and actuators and cameras and all the possibilities that Pepper has to sense what is happening in the game. But we also have the small pieces of Tangram in which players will have to arrange in order to succeed in the game. To provide a narrative of this, you can use many different methodologies, or you can also use many different stories. So in our research, we found that there is a very old Chinese book talking about the Tangram creatures. So we took that and we adapt that specific narrative, and as you can see, we put on Pepper's tablet, we are displaying the specific shadow or image that people will have to puzzle with so people will have to arrange using the Tangram puzzle. So we created an entire narrative around those specific animals. And to do that, we created a specific type of aesthetics of the game, which was using low poly models for that. So we took some low poly models, and then Pepper was displaying, for instance, a rabbit at the moment that the person was transforming to a rabbit, and then the challenge of the player would be to assemble the rabbit, the fox, the geese, and the lion. So for every game, you can try to do the same exercise of deconstructing it in the main elements. It's very important to recognize that all the elements of the fundamental tetrad are equally important. So although you can choose a game to have like a predominant effect in one of the specific game elements, like there's specific games that are very storytelling driven. There are some games that are mostly using a very sophisticated technology and are driven by the technological advancement. The most challenging aspect is actually to making them to work together. That's one of the biggest challenge of each game designer. And every time that you're trying to balance, that's how we call in game design, when you're trying to adjust the elements after receiving some feedback from players, you will notice that all of these elements are interconnected. So you as a designer, you have the goal of trying to balance them in a way that you are not certainly overbalancing to one specific game design fundamental or the other. That kind of like creating a cohesive connection among them. In order to design games, most of the times you have like a specific people with specific knowledge or specific skills to work in those individual areas. For instance, for writers, you have to create the story, the narrative, you have specific creative writers. To work with the technology, especially in the field of human-robot interaction, you need engineers to try to come up with interesting mechanics that can be suitable for one robot or the other. You will need game designers, which are the ones with the capability to see which game mechanic can be suitable for which robot. And in order to create compelling aesthetics, you will have to work with artists. I think this is when a lot of the challenges will start showing up. So in the field of human-robot interaction, when it comes to research, it's very hard to have all of these people in the same research lab or involved in the same project at the same time for them to be able, to contribute, to the creation of one specific game. So most of the times, what a student, master student, PhD student will have to do is basically to navigate through all of these problems along together with the supervisor and the co-supervisors. So for the game design process, once you have already some ideas of what you want to do, there is one specific process that is the one that I recommend when it comes to design games, which is a process in which you have to iterate multiple times. And the first element for this iteration is ideas. So you start having, certain ideas about, like, I would like this robot to propose players like an imitation game. That can be an idea. Then you start planning, around this. You start exploring how the robot can, create or elicit specific movements in participants to create that imitation. Then you go and start prototyping those ideas that you're having. After you have, what is called a playable prototype, then you go and try to do a playtest. Playtest is basically a user test in which you bring players to play with the prototype that you are creating together with the robot in the game, and you ask them for feedback. You create and you make an evaluation of that situation, and then you come back again to adjust your prototype, and then you go through that cycle as many times as possible as you can. So this specific design framework is called iterative prototyping, and again, you try to follow the 7 specific steps. You have to state the problem. You have to brainstorm some possible solutions to get to that problem. You choose one of those solutions. You list the risks that are associated with that specific solution. And then you start building different prototypes that are trying to mitigate those risks. You test constantly the prototypes. And at the end, you kind of like come back to the laboratory stating, a new problem that has been arising while people were interacting with the system. In the same example of using Pepper to moderate the gameplay while players were playing Tangram, which is a puzzle solve game. So I'm going to show you here one of the cycles that we went through when designing this game. So the problem that we identified, for instance, is we wanted Pepper to be able to recognize the pieces on a table. So we have individual pieces that were related to the puzzle, and we want Pepper certainly to be aware of how we were moving those pieces. So we sat down with the team and we started brainstorming on how to do it. So we came back with 3 different ideas. For instance, the cameras. What if we use the cameras? Pepper has a depth camera and some other cameras place it. I think Pepper has one camera at in the mouth and one camera in the forehead. So we were checking those. What the second idea was, what if we put QR codes in the pieces, or what if we use the tablet that Pepper has actually facilitate that recognition, so people will input manually when they were ready or when they were, going through the puzzle. We took one of the solutions and we started seeing how to use the different cameras of Pepper to basically get the shape, the shadow, the shadow with the specific shape that we were arranging when playing the tangram. So we use the camera that Pepper has in the mouth to avoid Pepper to, be turning down his head and avoiding that important eye contact when interacting with robots. So we noticed that some of the risks associated to this solution is, the puzzle orientation. Every time that we were having a different orientation of the puzzle, Pepper was detecting something totally different. So we're detecting a different area, or was detecting a different percentage that was not necessarily what we wanted at that time. So what we did at that moment is we conducted, or we prototyped a low fidelity prototype. So you can see here in the images that I was not even using the conventional tangram pieces that are a little bit smaller and wooden, but we were using some cardboard, basically colorful cardboard, to prototype those things in a low fidelity manner. And instead of using the cameras, because we were having a lot of troubles with Pepper's cameras, we were using external cameras for that. We did a test, an initial test with 3 lab mates, and we basically collected information and feedback about, what do you think about the experience, like how responsive you think Pepper was to, measuring the performance when participants were assembling the game. So one of the results that we found in this playtest is the game challenge was pretty low. So Pepper was certainly not, helping participants very much throughout the gameplay interaction. So we started adjusting, the helps and the cues that Pepper was giving to the players while interacting with the system. So again, that was, one example of, the complete steps while designing that specific game. But again, in order to design these compelling games and to create a very, interconnected relationship between the game and the robot, this design process has to be very iterative. And here are my recommendations to avoid, to feel overwhelmed, or to avoid to get to go through so many iterations without necessarily getting the results that you want. The first is just try to answer a specific question. So is Pepper capable to measure the game performance? Are players interacting more than 50 minutes in an enjoyable manner with the game? Is the game capable to foster conversations between participants? So these are specific questions. Then you try to forget about the quality. So you start working with low fidelity prototypes. You start working with paper and pencil prototypes. And even if you have to use the Wizard of Oz in the robots, that's also good. So you don't have to program all the autonomous behavior of the robots without knowing that, that's the concept of the game that you want. If you can, make prototypes in parallel. That's a little bit hard when it comes to working with robots. But imagine instead of one student, you have, another colleague working along with you and trying to do this. So you can work in different prototypes and use the robot to test different things. So it doesn't have to be sophisticated. So it doesn't have to, be using all the sensors and all the capabilities. So the most important thing throughout the design process is to realize that the game that you are designing or you're creating is fun, is enjoyable, and is meeting, all the requests and on all the requirements that you're designing it for. And then once you can, just try to pick up some agile tools. For instance, if you don't have the robot, you can try to work with simulators. So if you have the robot, so just try to use external sensors if for some reason the sensors on board the robot are not working properly, or just use some Wizard of Oz capabilities of the robot to simulate some of the possible responses of Pepper or of the robot while you are interacting. So in a nutshell, how do you move from one idea to a game is think of an idea or a set of ideas, try it yourself. So first, before going through all the play tests with the participants, I always try to, play my games, my own games, and try to, deconstruct and like the elements that I would like to have and I would like to see in my game. So you try, after that, you try again with other players, and then you keep adjusting it and testing the game until it seems good enough. In this case, for on a specific experiment or for a specific test you're trying to accomplish. To finish this, I would like to share with you 3 of the main challenges that I foresee or that I have been encountering when designing games with robots. The first of them is, of course, the robot's capabilities. So when designing games without involving robots, you certainly can use one game mechanic across many different games, and the games can still be, enjoyable. You can still use, I don't know, specific imitation games. You can still use specific guessing game mechanics without the need to recreate the same game mechanic in a different game. You can make it fun. Some of the limitations here is each robot has, very specific capabilities that might require some games to be really tailored to the specific robot's capabilities. The second challenge that I'm seeing here is actually play testing with robots can be very time consuming. So, when you're creating conventional, board games, you can, test a lot with, paper and pencil. You can just draw, and then you can do a quick play testing. Same thing for video games. When you're doing a video game, you can create a prototype and you can put a sequence of, 8 computers, and you bring 8 people to play the game at the same time. But when it comes to robots, most of the time you have only one robot. So you have to work with that robot and test with that on the robot. And also something that I mentioned before is the design team. So when trying to work closely with game designers, trying to work with engineers, try to work with people in the creative writing side, or people in the artists that can create compelling visuals and sound for the game is certainly problematic when it comes to designing games with human-robot interaction. So there was a very brief description and talk about the game design fundamentals in human-robot interaction. So we have some other content that I highly encourage you to visit in our tutorials website. And I'm running this tutorial together with Professor Kirsten Dottingham, which has fortunately a lot of good expertise in the field. So you can visit us in the Social Intelligent Robotics Research Laboratory at the University of Waterloo. And we have also created a website for the game design taxonomy that I will be also presenting in a different lecture. You can visit us in roboludens.ca. Thank you.